Hello everybody, we are continuing class 12 physics chapter 2 electric potential and capacitance. In this video we will be discussing equipotential surface and its properties. First we will do equipotential surface. I am Anandavali, and before we start the class, please watch the video completely so that you get all points cleared. And if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. Press the bell button and all button near it so that you get intimated as soon as new videos are posted. Thank you very much. Come, let us start the class. Equipotential surface. As the name suggests, it is a surface where the potential is equal. Equi means equal. What is the condition to be satisfied for a surface to be equipotential surface? In order to understand this, we will consider a point charge at a location. We have considered a positive point charge. Let Q be the magnitude of the charge. All around this charge, there will be an electric field, and different locations in the electric field will have different potentials. Let us consider a few locations around this charge at equal distances from the charge. If these points are connected, you get a surface. Any point on this surface will be at the same distance from the center of the charge. What will be the magnitude of the electric potential on these points on the surface? Potential is equal to kq by r. R is the distance of the point from the charge. K is a constant, and for the given charge q is constant. As per the diagram, all the points on the surface is at equal distance from the charge. So R also is constant. So potential on all points on this surface is the same. So this surface is an equipotential surface. The condition for any surface to be an equipotential surface is that all points on the surface should be at equal distance from the charge. We may consider any number of such surfaces outer to this given surface or inner to this. We will consider one more surface which is outer to the surface which I have shown here. Points on this second surface will be at a greater distance when compared to the distance of the points on the inner surface from the charge. As the distance increases, potential decreases. The second surface also is an equipotential surface, but the potential on the second surface will be less than the potential on the inner surface. Actually, we should visualize these surfaces in 3 dimensions. That is like a sphere or a ball. The charge we should assume to be in its center. So, all the points on the surface will be equipotential. What are the important properties of equipotential surface? In order to understand this, we may consider this spherical surface to be made up of several small delta surfaces which are so small that they can be considered as plane surfaces. All these surfaces can be considered as equipotential surfaces because they are elements of this big equipotential surface. Now we will consider one such element as magnified. Consider 2 points A and B on this equipotential surface. The charge Q is placed at A, and if it is moved towards B on this equipotential surface, then the total work done in moving this charge from A to B is equal to 0 because these 2 points are on an equipotential surface. Let the displacement be equal to dr and its direction is from A to B. The first property of equipotential surface is that work done to move a charge from one location to another on an equipotential surface is equal to 0. How can we prove this? Since this is an equipotential surface, VA, the potential at A, is equal to VB, the potential at B. We know work done AB is equal to VB minus VA. That is the difference in the potential between the two points or locations. For unit charge, this becomes VB minus VA divided by Q. But VB minus VA will be equal to 0 because we have already seen VA is equal to VB. So work done AB for unit charge divided by Q is equal to VB minus VA, which is equal to 0. If so, work done in shifting unit charge from point A to B on an equipotential surface is equal to 0, then the work done for shifting any quantity of charge, it may be 5 coulomb, it can be 10 coulomb, it can be 15 coulomb. Work done for shifting any quantity of charge from one point to another on an equipotential surface will also be equal to 0. So, we have proved the first property. Second property, direction of electric field is perpendicular to equipotential surface. It means it is perpendicular to the surface that is shown here. That is at 90 degrees to this surface. We have considered a positive point charge here. So the electric field will be directed outward, that is towards the outside. If you consider a negative charge, it will be directed inward. In both cases, it will be perpendicular to the equipotential surface. That is, for a positive charge, the electric field will be directed outward from the equipotential surface at 90 degrees. That is outward. If it is a negative charge, then it will be directed downward. That is towards the center of the charge. Now we have to prove this statement that electric field is perpendicular to equipotential surface. Work done also can be calculated as equal to the dot product of force and displacement dr. Both are vector quantities. Dr is the distance through which the charge moves from A to B. F is the electrostatic force due to the charge and it is equal to EQ. For unit charge, that is 1 coulomb charge, F is equal to E, the electric field. Substituting for F, the equation WAB is equal to E dot dr. Both are vectors. Under the first property, we have seen that the work done AB is equal to 0. So E dot dr will also be equal to 0. E dot dr is equal to E dr cos theta. Theta is the angle between the two vectors, the dot product of which is calculated here. That is direction of electric field and direction of displacement. Electric field E has a magnitude. The distance dr also has a magnitude. Then how can E dot dr be equal to 0? For that, cos theta should get a value equal to 0. We know cos 90 degrees is equal to 0. That is the angle between the direction of electric field and displacement should be 90 degrees. So the direction of electric field and the displacement may be represented as is shown here. You can see that they are mutually perpendicular. The direction of motion of the charge, that is direction of displacement dr, is on the equipotential surface. So instead of direction of displacement, we can say the equipotential surface. So the direction of electric field is perpendicular to equipotential surface. For negative charge, it will be in the downward direction. Of course, it will be perpendicular. Please do not forget to subscribe, like and share my videos to your friends also. Press the bell button and all button for notification of more videos like this. Thank you very much for your support. These two properties of the equipotential surface is very important for the examination. It is a favorite topic for the examiners. We will discuss more about this topic in the next video. Till then, bye. Take care.